ultimately honor the people who are in our data with better analytics and yeah, better analytics, better reporting. You're going to hear some interesting use cases today and some discussion about community work using AI with claims data and some issues of bias. The format for this will be short presentations from each of our three guests, and then we'll move to a question and answer period. We're honored to have three experts with us today. We've got John Duke from Georgia Tech Research Institute, Allison Fox from Mathematica, and Monika Ray from University of California, Davis. I want to thank all three of you for being here today to share your experience and your wisdom. And with that, I will hand it to John.
Well, thank you very much, Paul. I appreciate it. And thank you, everybody, for joining today. I'm going to share my slides, hopefully, here, and they'll get going. So just one moment. All right. Let's see if the, all right, are you able to see my slides? And let's see, they should be going into full here. Are they there? If somebody can let me know.
You see them in full screen now.
Great, thank you. So again, my name is John Duke. I'm at the Georgia Tech Research Institute, and my center there, we're the administrator for the new Georgia APCD. While we like to sometimes get into the very bleeding edge at Georgia Tech, I did want to emphasize and actually talk a little bit about today, maybe some of the things that are more standing historically in the space of AI, and then during the conversation with Paul and the others to talk about some of the newer things. But I think this is an important piece that's very relevant, which is that AI in health has been around for a long time. A couple of the, kind of big emphases were really in the 70s and 80s, where people were developing systems to automatically do diagnoses, and they were using a lot of data that they had available, such as it was, to try to explore. And one of the challenges that we've seen is that the scalability and the shareability of innovations in sort of AI in healthcare and in health-related analyses has often been limited by interoperability. So I think, no doubt, much of our conversation today will include some of the newer sort of AI models that became popular in late 2022 and last year. A lot of the excitement about those is that they can enable a certain degree of automation, and that you can put in information, you can put in even a small data set and ask questions, and it can figure things out. And there's sort of an example here where there's some aggregate data, and I'm able to ask a bit about, the rates in certain counties of this and that, and it's able to do that. There's a lot of those sources out there. But I would still advocate and suggest that at present, in order to really scale and build an AI strategy that is going to sort of work broadly, be able to be shared with other organizations and within one's organization, interoperability of data is still really critical. I particularly want to highlight and talk for just my few minutes today opening about a standardization framework that does include AI that we use in the Georgia APCD, called the OMOP Common Data Model. OMOP is a data model that has been around since about 2008 officially, but really 2013 is when it truly expanded. And it's really a claims and EHR focused data model and data structure. There's a very significant worldwide collaborative of organizations that use this same data model for a wide variety of purposes. OMOP as a data model, and Odyssey is the organization. OMOP is the name of the data model. OMOP as a data model has a lot of built-in tools that can be used. And in particular, there's things, of course, for exploring your data, and there are a lot of nice things that I think people have developed to varying extents, for example, for APCDs. But there's also a pretty strong predictive model development set of tools as well, where you can define populations of interest, You can define exposures of interest. You can define a type of analysis that you want to do, and actually performs and runs a wide variety of analyses. And I wanted to click over here, and I'll probably have to just switch over real quick on my screen share to show a little bit about this. But basically, by using this common data model, you can utilize or test models that have been developed by a wide range of experts around the world and apply them to your data. So I'm going to click here, and it's probably going to jump over to another environment. So let me just quickly switch my share in order to show you what's popped up. The example here is a viewer of a data model. This particular one happens to be focused on COVID, and the screen, I'm sorry, the letters are quite small on my screen as well, but the main thing to convey is that this is the output of using this structure, is that you have a set of definitions that have been created that allow you to say, I want to look using a neural network model or random forest model, regression models. I may want to use a particular database, a claims database, or other sources, and I have a particular cohort of interest. In this case, it's looking at COVID and outcome risk. And then there's all the sort of performance metrics and characteristics, as well as an ability to sort of look at how this model did, the number that were predicted positive and negative, and to build on top of this. It's a lot to sort of in one bit go over, but what I wanted to emphasize, there's truly hundreds of models that have been built and developed and evaluated by experts around the world using this same model, which is sort of focused around the use of claims that can be leveraged, reused, tested on your own data, and then incorporated potentially into tools or other use cases. So I'll close just by saying that the kind of decision to incorporate, let's see if I can, yeah, the decision to incorporate particular elements of AI into your strategy, I think should probably have a couple parts to it. One is based on the newer AI space, the idea that there's a lot of new generative AI and other kinds of areas that are exciting, and I think we're going to talk more about. There's a lot of potential there, but I think there's a really critical opportunity to look at some of the work that's been done in AI and ML to make it more accessible and useful broadly, and how that might be able to be applied to the data that you have now. So I think really the key piece is that working with AI going forward includes sort of exploring the new, but also taking advantage of what has been built up to make it more accessible over the past several decades. So I will turn over to the next speaker. Thank you very much.
Thanks, John, and thank you everyone for coming today. I'm just going to go ahead and share my slides here. Are you able to see the deck okay?
We are, yes.
Awesome. So I'm Allison, and I'm a data scientist with Mathematica, where I help government entities and various healthcare organizations to design, develop, and then deploy AI systems. And today I'm going to talk through some strategies for building responsibly and an example AI project that we did at Mathematica. And so just to kind of kick us off, as we've seen in the news, there's been a bunch of cases where AI systems have had positive impacts, such as helping public health systems to predict COVID-19 surges. Yet there's also been some cases where AI systems have had negative impacts, where they've amplified the biases that exist in our society. And at the end of the day, these machine learning models that we're building are really nothing more than Python code themselves. Yet there's a bunch of decisions that we make as humans when we're building and using these AI models that really dictate whether the AI system will be helpful or harmful. And the first one of these is really the goal that we as humans are instructing the code to achieve, or what the model is predicting and how it's predicting it. So an example of this that surfaced recently was a large healthcare insurance company was using AI to identify high-risk patients. And the model was predicting cost instead of illness. So in this case, the outcome of interest was not actually being used, but a proxy variable. And In this case, the model was extremely biased against Black patients and scored them as being a lower risk than white patients, even when they had the same level of risk. And in this situation, the way in which the programmers formatted the model resulted in the model being biased. And secondly, the systems that are built around the machine learning model as it's deployed really influence how the model will behave once it's kind of in the wild. And so if a model is deployed in the EHR, for example, and it's flagging high-risk patients for clinicians, then the clinician should be able to see what variables in the model were most important when making the prediction. And lastly, the way in which the humans interact with and use the model's predictions really determines whether the AI will be helpful or harmful. So for example, it's important to have a human in the loop, like a clinician who's reviewing predictions and considering that prediction in combination with their expert opinion before they're making a diagnosis. And so given these things, when we're using AI in our projects at Mathematica, we really view it as a tool instead of a complete solution. So it's something that enables our work to be more evidence-based and helps us to make sense out of all these large amounts of data, but it really has to be used strategically. And so to reap the benefits of AI, we've found that it's really important to build thoughtful and ethical systems around these models. And so to ensure that we're building an AI system instead of just a model, there's a few concrete things that we can do. The first is that ensuring the AI is really appropriate for the use case. And this is often an analysis of whether the risks outweigh the benefits. So for example, with chatbots that provide mental health services, the capabilities of generative AI may not be advanced enough yet to respond to a situation like that, which requires a pretty high degree of social and emotional intelligence. And second, we make sure to scope the project really thoroughly upfront. So this usually involves elements of human-centered design to make sure that we really understand what problem the model is actually going to be solving and how the predictions will be used. And lastly, we involve subject matter experts in the AI development process. So for example, if we're building an AI solution that's going to summarize patient visit notes, we'd first want to talk to a clinician to better understand how they tend to structure their visit notes and what information would be important to capture in the summaries. So just to illustrate some of this, I want to walk through a project that we did at Mathematica, which was the CMS AI Challenge. And in this AI challenge, we developed an AI model that would predict unplanned hospitalizations and nursing home admissions. And so when we started the project, it was really important for us to understand the use case and what the AI predictions would ultimately be used for. We wanted to provide a tool with the primary care providers in mind, with a focus on creating something that could be used in real time during the patient visits alongside of the patient charts. So the main goal was to help with the increasing caseloads and the financial risk that these providers face. Given all of this, we built a model that predicted the risk of unplanned hospital admissions within 30 days of common healthcare encounters. Basically, the model would classify high-risk patient cases to support in-office decisions. So the next step was then data selection and exploration, and in this case, the data was pre-specified by the CMS AI Challenge. We used the 5% LDS sample, which is a standard CMS Medicare claims data set that's available for research. And we had data from 2013 through 2017 with about 2.8 million people and 230 million claims. This is a pretty good data set in terms of representativeness, but the weaknesses of a sample come when we're working with small subgroups. So then moving on to building the model, there are a bunch of features that we use, some of these listed here. Claims-based features, mostly diagnosis and procedure value set-based variables and quality measures. And then we also use some social determinants of health measures and a few other data sets. And then after we built the model, it was really important to see if bias existed in the model and whether the model was treating individuals fairly. A major cause of bias in models is bias in the data. So we compared our training data from CMS to the overall Medicare fee-for-service beneficiaries by age, gender, and race. And we did some basically reweighting of the observations to adjust for the bias that we found in the data. And then lastly, bringing in that explainability piece with clinicians that I talked about earlier, we built explanatory displays to basically show the predictive results from the model to the providers to help them with decision making. And as part of this, feedback was gathered from clinicians and patients up front. And I want to wrap this example up with just a few of our key takeaways. The first was that bringing in the right stakeholders was really crucial. There were a lot of different experts that had to be involved in this process, including clinicians and patients, and that was really important to ensure that the model was built responsibly. And second, we found that it was really important to check for bias in the data. This plays a big role in biased model predictions, so we wanted to make sure that our data was representative. And then lastly, making sure that the predictions from the model were very clear and useful to the end user. So just to conclude all this, I want to mention a few things that have been top of mind for us at Mathematica lately, especially with the evolutions in the generative AI space. First, domain-specific AI must be developed for it to be trusted and safe. And even more granularly than that, a model that's maybe doing a good job of identifying high-risk patients in rural California isn't necessarily going to do well when it transfers to New York City. So this is similar to how John talked about. You have kind of these baseline models that you can work off of and then adapt them to your own data set, which is a great approach. And then second, in terms of where and how to start with generative AI, some productivity and documentation tasks are some good kind of low-risk opportunities that should be considered early on. And then lastly, when it comes to the data considerations, a big piece is the maintenance and the monitoring of models. This is a very heavy lift, and given how quickly healthcare is changing, it's unlikely that you can really just develop a model and not have to retrain and test it frequently to still get good results over time. So I will pause there and pass it over to the next speaker. Monica, if you're speaking, we are not able to hear you.
Oh, sorry, I didn't know we were waiting.
Problem.
I shall first try to screen share. Can everyone see my screen? Teams doesn't seem to work very well with my system.
Yes, we can see the slides.
Okay, wonderful.
For what it's worth, Monica, they're not in a full screen mode, so we can kind of see your the
note?
yeah, whatever. Maybe, yeah, there you go. All right, looks great. Thank you.
Okay. So hi, I'm Monika Ray. I am a computer scientist and my training was in AI and robotics. I currently am with the University of California, Davis School of Medicine, and I have been mainly working with developing risk adjustment models and various applications of AI and non-AI to explore data. So these are some of the applications of AI. And the first being pattern recognition, which also is known as unsupervised learning. And this is the case where you look at large data and you look for novel patterns or identify unknown patterns from large data that you can later on take for hypothesis testing or validation. So this does not involve the use of data splits such as training and test sets. The other forms of AI, which are supervised learning or semi-supervised learning, those are your predictive models where you have an X equal to an outcome Y. And this is where you actually want to study the impact of certain features or risk factors on an outcome that you're studying. And this is where you actually have the concept of training and testing data. So depending on the objectives of your research, you could choose to do one or the other. And some people prefer doing pattern recognition to identify hypotheses to test in large data, as well as other people who might have certain hypotheses to test, and then they would actually be doing more of the supervised learning approaches, where you actually, this concept of supervised learning comes from the idea that you have labels, the outcomes are known and are input into the model, as opposed to unsupervised learning, where you're not learning the outcome, you're actually identifying global or local patterns that are hidden in large data. So one of the things that has come across quite frequently in large data is the idea of data bias. And this usually in healthcare comes from missing or incomplete data, but not all forms of missing or incomplete data will introduce bias. There are times it will, sometimes it wouldn't. And therefore, it's important not only to identify the missingness and the kind of missingness in the data, but also to understand the ramifications of such characteristics of your data, and then consult with either the statistician or the analytical team in order to address the bias or the missingness, or learn to live with it. But the fact is, you have to acknowledge if there is any form of missingness and potential bias your data might have. The other kind of bias is in the model. So as you can see in the top right graph, where you have the two components of machine learning that gets optimized or balanced through optimization theories, which is the variance and bias. So the main purpose of machine learning is to keep a balance between variance and bias. So as you have highly complex models, you will decrease bias, but you increase the variance, and that's not something we want. So finding an optimal model is the biggest challenge of developing AI models. It's not that you will always get the most optimal one, but you try and you strive for that optimal model. So this is the phenomena of the model being biased as opposed to the data being biased. So this is another point to check in your analytical pipeline, that you're not under or overfitting in order to keep this balance between bias and variance. Then coming back to some of the current topics and thoughts, which is that, of course, the world is now in a big upheaval about AI and its impact in society. And we are all aware of those conversations, and those conversations will continue, the debates will continue, but we have to remember that change does not happen overnight, and it doesn't happen painlessly. So in order to engage more of the public and their trust, one has to do it over time, slowly, as well as educating the public about what is being done to address their concerns and their struggles as we adopt newer methods, whether it's AI or not. So, and also the fact that people developing AI should be held accountable and transparent as to how they develop the models, what kind of data were being used, and how are they protecting against unnecessary harm. So the final slide I'd like to bring up is that AI is not new. It has been there long before I even began in the field. But the advent of large healthcare data to mine is new. And therefore, now people are curious and eager to use AI methods. But it's important to know the theory behind AI models, the statistics behind generalization to unseen data. It is also important to know that AI does not solve the fundamental problems of incomplete data, unavailable data, or data accuracy. But it can be used to identify these gaps sooner than later. But there are many ways we can use AI for the data we have today without getting as fancy as ChatGPT or LLMs, which is that we can use it in domains to ensure greater data encryption while still allowing for the longitudinal tracking of patients or subjects to understand quality of care over time. The review of IRB proposals can be revamped to allow for another layer of scrutiny if an AI method is being used, as well as the fact that a lot of people who do not know AI or the analytical pipeline may not know to check for certain logical flaws or other unaddressed issues. These things can be also addressed through AI tools to ensure whether a proposal has addressed those issues, as well as checking the models for bias, interpretability, explainability, and such. But AI also can be used, especially in today's age of working on data that is all over the globe. There is this strong push to not remove data from its geographic location because the ethics, the rules, the policies that apply in different countries are different. And therefore, in order to be fair to the citizens of other countries and other regions of the world, we should look into federated learning approaches that do not require data removal from its original location. Another thing is to look into unsupervised AI to generate testable hypotheses that is supported by the data at hand, and not try to force a hypothesis or force a test on a data that is not well suited for that question. So at the end of the day, the idea is to reduce the growing divide between the public distrust and the group of people that know how to address these issues with proper tools and checks in place. And as I would also like to end this with the concept of humble AI, which is that you align AI with our moral aims, which means we have to constantly show the public that we respect their concerns about AI affecting them, and sometimes showing compassion when we override our desire for model performance and efficiency over certain things that may worry people more than actually gain their trust. And I would like to also end this slide on a lighter note. I grew up in the Middle East, so that's my second home, and so I'd like to show this. It's not? Is it not showing? Okay, I think I moved the screen. Basically, this is the concept of a robot delivering medicine to patients.
Monika, we're still seeing your slides. Just
You might have to reshare your screen. Unshare and then reshare.
Oh, well, I'm going to try showing one of the best uses of AI. I'll try to share my screen again, is the fact that you can deliver things like medicines to people who are in remote areas and such. And that is one of the good causes and uses of AI without scaring the public. So that's from Fakeha University Hospital in Dubai. So there are many good things that we can do to gain and engage public trust in AI solutions. Thank you.
Thanks, Monika, and thanks to the rest of the presenters. This has been fascinating and a lot to think about. To piggyback, I think, off of the last kind of topic that you were touching on, Monika, in terms of oversight, is there legislation that's impacting how we use AI, either at the state level or federally? And I guess, should there be?
Yes, actually, there are a lot of White House reports, and I believe Allison Fox is probably more eager to talk about this. I'm just a scientist who's, doing my scientisty things. But actually, the confusion with legislation is sometimes the wrong people are not called at the table. And our concepts of what's fair and transparent in society seems to change year to year, demographic, not even demographic, people to people. For example, we do not like car crash. I mean, we do not allow for plane crashes, right? We have a very high, stringent law against airplane crashes. However, we have tons of Google driving vehicles on the road with 40,000 plus accidents. So sometimes society is willing to allow risks in one area versus another, and where that area is hard to quantify and put into legislation. But that doesn't mean we shouldn't have conversation as to how far we can push it. But I'll leave it to Allison because I think she has more info on that.
Thanks, Monica. Those are all really great points. And I agree. I think legislation can kind of do a good job of setting up broad guardrails, but it's very use case specific when it comes to actually deciding what it means to be fair and how to measure fairness and how to make sure that the model is deployed in a responsible way. So as was the case with GDPR and data privacy regulations, the EU is making some good progress in this space. And there's the EU AI Act, which lays out a bunch of pillars of responsible AI. So things like fairness, transparency, accountability, privacy, and security. But the next step is really for all the stakeholders to be brought into the room and translate those kind of pillars and broad guidelines into standards. So what does this actually mean in practice? What are kind of the day-to-day implications of these regulations? And in the US, Biden recently put out an AI executive order that mirrors a lot of the principles reflected in the EU AI Act and is a good high-level kind of overview of where the US needs to head in terms of building guardrails for responsible AI. But there's definitely a lot more progress to be made in terms of thinking through what this actually means and looks like in practice and how that varies by sector as well. And I think one example of some more sector-specific legislation is that DHHS recently finalized the HTI-1 rule, which establishes some transparency requirements specifically for certified health IT. And these requirements aren't necessarily like you must pass this threshold, but really just setting up some broad guidelines around the algorithm information has to be provided and made public, and that the model has to be able to be evaluated by clinical users for things like fairness and validity and safety. So really just trying to start the conversation around a lot of these things and kind of bringing those other metrics like fairness more to the light like we often think of accuracy.
Fantastic. Yeah, that's great. That is great insight. Yeah, it's amazing how these topics don't ultimately change. Even when we bring in this new technology, we've got a lot of the same problems. In terms of kind of where we are, if I'm taking the perspective of a state, we've got an APCD, we have limited resources. I'm kind of curious what kind of AI applications are available to us today, what kinds will be available soon that would maybe be accessible to an organization like ours?
Yeah, I think that's a really interesting question, Paul. There's sort of maybe two sides of it. There's kind of the AI applications that you might use within the organization or to make things sort of more efficient. I think many of you on the phone probably have seen the value of AI for generation of code, and it's really been quite good. So from that perspective, creating SQL queries, creating Python queries, even creating visualizations, if people haven't had the opportunity to run the latest, you can ask ChatGPT-4, here's a picture of visualization, I want to create it, but using these data. And it can give a pretty good shot and give you a Python code, Jupyter code that you can run. So there's kind of like the aspect of AI to help my work. And I think we're seeing a lot of that. It's moving very quickly. It's moving quickly in the education space. It's moving quickly, certainly in this sort of applied area on data. But then I think a lot of what we've been talking about here is around kind of the classical machine learning predictive model generation in order to inform and support the stakeholders in our data. So people are interested in, what individuals or what groups or counties may be at risk given for particular outcomes, particular adverse events. And that's a different set of things. And I think we've talked about many of the areas here. I think the tools, at least the one that I described, these are open source community tools. They're designed to facilitate kind of researchers working on these kinds of data. So I would think about sort of the AI tools I'm going to use and the AI tools that I might use to build a model to go out to support my stakeholders.
Great. That's, yeah, I always like something to bring back to the team. So that's great insight. I'll jump to the questions from the audience. We have the first question here is, due to mistrust issues, have there been any attempts to rename these processes?
I think this is a little bit different, but one thing that comes to mind for me is that AI is often kind of anthropomorphized, and we treat it like this human that makes its own decisions and has autonomy. And I think talking about it as AI systems and thinking about the broader system in which the AI is deployed, as opposed to the AI, I think is one step to kind of bring to light how these systems really work, as opposed to how we often just think of them as being these autonomous things that control everything. At the end of the day, humans really should be involved in all of this still. So I think that's one thing that helps with kind of the narrative around AI.
I'd like to add in here that the question was, has there been any attempt? I can say I have told people, don't use the word AI. Mention your method, because there is a whole, it's a suite of tools. It's not one or another. But I'm told that apparently we don't get funding or we don't get the ticket to enter events if we don't market it like that. So there is that tension between staying very grounded and honest that I'm just using this. It is using some components of AI, but it's not, I've not lost control of it. I know exactly how to handle it. But then apparently that's not what people are excited by. So then people try these new terminologies, and that is the tension, that you can't say, use normal bland words. So there has been attempts. I have done it many times, but apparently if we don't use fancy words in our titles, in the titles of the work, it doesn't get visible. It doesn't see light of day.
That's very interesting. That's a good call out for that tension. All right, next question from the group. How do you reference AI and methodology, academic and/or analytic work to enhance transparency and reduce the impression of plagiarism?
Certainly, I think we're in the middle on this one. I should know from a academic side and in coursework side, there is a lot of gray and maybe darker shade of gray around AI referencing in academic work, at least in student work, and I'm sure I'm moving beyond it. I think one of the things that we try to do, and I'll just kind of like take it more from the project perspective when we're working with a group that's trying to look at a particular question, is to talk about upfront how we think collectively it would make sense or not to incorporate AI into this effort. So one option is to say this is a no AI zone. We don't want to use AI, and from this perspective, I'm talking about generative AI, which is I think where you're talking about some of the plagiarism and things like that. The second is to say we think there's some areas where it could be useful, and why don't we call those out, talk about the guardrails that we want to put in place in order to use AI effectively, and as you point out, to document what we've done. And then third is kind of like a AI forward sort of stance, where one of the goals might be to help educate the stakeholder about AI. They're interested in saying, we think maybe this would be something we'd like to explore more over the course of this project. Can we try to use AI explicitly because we want to learn more about it? And so I think a key thing, it doesn't get to the question of how to reference it explicitly, but I think in terms of the actual collaboration of work is to be transparent about how you frame it and move forward on a given project.
I'd like to add that there is no limit to the number of citations. I mean, to be very honest, a lot of these methods are very well established. Unless you're coming in from math, physics, computer science, you should be citing other people's work and mentioning you are using AI. And there shouldn't be an impression of plagiarism if you cite and you also cite code. If you have used other people's code, like in GitHub and stuff, mention it. So there are many ways to ensure that no one is going to accuse you of plagiarism. In fact, once someone accused me of plagiarizing, and then I found out this was because an AI model told them I plagiarized, and then they showed me the paper and it was my preprint. So this is where, you know, there needs to be a conversation. You have plagiarized, but they are actually looking at my own previous work, and yeah.
That's a fascinating example. Yeah, that's very interesting. So I've got a question here about some examples of current use cases of APCD projects, and then asking if you could brainstorm how AI could support or augment those use cases. So when I think of APCD current uses, one of the big ones is around understanding and controlling price of services in healthcare. Is there anything that you think would be uniquely important or uniquely valuable that AI could bring to answering a question around that? And maybe that's too general for a discussion about what model would be applied, or if there is a technology that you would use. I don't know, anyone?
I think that goes into the weeds of proper predictive modeling, because you're going down to cost, right? Are you referring to the healthcare utilization costs for the different medical services?
Yeah, yeah, exactly. When we look at cost and utilization trends over time, that kind of thing.
Exactly. And so that's a domain where you have to also, so a lot of the times what I find in proposals is if you are dealing with costs and you have a team members that don't have an economist on the team or someone who has done a lot of the finance work, it tends to be, they tend to develop very biased insular models that do not generalize because they do not apply the right principles from that domain. So if you are, I have never worked on cost analysis, but I do know others who have. And the component they keep missing sometimes is the finance, the economist in the team.
Yeah, I would say certainly in the cost area and utilization. I mean, a lot of the classic kind of questions that are applied would be looking, whether you're interested in the sort of provider or geographic area, or looking at characteristics, specialty. I mean, there's so many areas where AI could be applied. I think it really comes down to making sure the question is of use, and that the sort of characterization of data, which is what APCDs are incredibly strong at, given often their scale, is very, very valuable. Hopefully that then prompts some questions or hypotheses that can be tested sort of in a statistical way. I think where you're thinking about machine learning is going to be more looking at what are the adjustments or changes, right? So it's sort of almost on the simulation side when people think about access to care and think about what are the changes that could be made, and if they were made, what might happen. So I think there's definitely opportunities in sort of that kind of modeling and simulation space where AI would be quite relevant, and cost would be a huge part.
Actually, to add on to that, this is exactly where you'd like to do unsupervised learning, to identify these patterns before you deploy a parametric model. So it's important to identify if the data you have supports the concept you're testing for. And that should be, therefore, the phase that one should go through is this unsupervised learning to identify patterns in the data, and then study those patterns with more rigor at the next step.
Yeah, this is great. I love the conversation about what opportunities there are here. Question kind of on the other side. I know that a lot of us are pretty risk averse when it comes to security, privacy, that kind of thing. Are there some risks, some mitigation of those risks? I guess just generally, what advice would you have for addressing that concern?
Yeah, at this point, I think this is probably a pretty big topic for which there's many day conferences devoted. But I would say in general, as with the actual practice of healthcare and how AI is playing in that, I think we're really talking about teaming, right? Human AI teaming and that kind of thing. And I think that's really critical. The notion definitely of just kind of pulling something down. Although we've seen it as with the GitHub code references mentioned, obviously we've seen many huge scenarios where there's a standard piece of code that's all over the place, and then a vulnerability is found, and it leads to widespread risk and vulnerabilities. I think kind of in a similar way here, not to sort of bring something in without trying to ensure that you understand it and it's not kind of done as just baking it in. But I think it's really a fascinating issue and one that I don't have a quick answer for.
I'd like to add the fact that as in law, we have the situation where we cannot foresee every situation in advance. This is the classic example of game theory, which is that every move you take, you can't predict all the possible moves others are going to take. So you'd like to enumerate and illustrate all the potential ways you can or cannot use data, model, code. And you keep updating that list. But you can't say this will last till for the next 100 years. That's the pure idea of game theory. There are always ways to get around it. But I also feel that there should be ethicists or bioethicists that need to be part of these conversations.
I think another new potential security risk that evolved kind of recently with generative AI is just being really careful not to leak any data. It's such a new tool that we're not entirely sure how it's going to work in different contexts. As Monica's saying, you really can't predict everything. And there have been cases of where it's kind of like plagiarized training data exactly as it is. And so one thing that comes to mind to me is just HIPAA and data privacy and patient protection around all of that. I think will be something that's really important to consider from a risk perspective when working with new generative AI solutions.
Great. Yeah, you're definitely, I think, speaking our language with that one. Next question here from the audience. Each of you spoke to the ethical considerations of the use of AI in reference to the models derived from it. Do you have any insights on the other unintended negative consequences of AI systems, such as exploitation of human workers who collect and create some of the data used in AI?
The list is quite long. I think whether it's insights at this point or kind of restating, I think the many concerns have been raised. There's no question that the harms of reusing or how the data are used can range from one to just some of the biases we've seen foundationally, like again in healthcare decision support systems, and the idea of bias that can be relate to gender or race or other factors that are built in. So that's kind of well-established problem. And then there's sort of this next level problem around is it trustworthy? But you've raised like what is the harm to the creators, which we know is something we're certainly seeing play out now. So I think we're only beginning to unpack those. I think there's going to be a whole expected wave of kind of AI on AI, because so much AI generated data is coming out, and there's going to be a lot of things that are going to be trained, and whether it's reinforcing barrier biases, whether things can be separated. I know there's a lot of effort to try to make clearer what is, kind of, AI generated data, what is not. But I think ultimately there will be impact on those who've created and contributed to these systems being successful. And it definitely will not be all positive. I think it's a very legitimate concern.
Well, I think I'd like a clarification. Is this about APCD or is it the entire universe? Because I see that we've always collected data, like we have imagery and defense. But if this is about writing books, authoring, film, music. Is that what this question is? Because I don't know who creates my data. When I get data from HCUP or somewhere, I don't know who that is. But of course, if I'm going to plagiarize someone's book, you know, who has, and there's an author there. So I'm not sure I understand the question and its connection to APCD.
I think I see that a little more, a little broader about the learning side of a model and exploitation potentially of people on that side of it. I think that's how I interpret this question.
Okay.
All right. Next one here. We're getting short on time, but I think we've got time for at least one more. And this is a specific question. I'd love to hear kind of a direct path for this, but it's might we use AI to identify unexpected top factors in driving higher costs? So other kinds of factors like location, organization ownership type, age of clinician, some of these things that maybe we don't have our eye on, but turn out to be especially relevant. And this is around generating a hypothesis.
Yep, it's the unsupervised learning. There have been a lot of discoveries made from unsupervised learning. Some of them very exciting to follow through, some of them deeply concerning. So it's important to study that. Actually, for me as a scientist, I enjoy that more. I leave the clinicians to hash out what risk factors, but I really enjoy the data identification from or pattern identification from large data when it comes to opioid treatment, medication doses towards a certain outcome and stuff. So it is a powerful tool to use to generate new hypotheses to test using smaller data. I'd also like to bring up one point I think we probably missed. As we get large data and more complex models, the computing systems also need to increase alongside. And not everyone has that ability financially from the institution side or their own coding expertise to leverage all the uses of large data and scalability of models. That I would like to know how APCD is addressing in terms of allowing for that in their models or their platforms that provide APCD access, data access. So because a lot of the people, you say that I only took this subset of data because I don't have space and computation requirements to run it. And so by default, that is a biased model, but that's driven by financial and computational costs.
You know, I would connect, you know, back to from that to this sort of initial question. I think in some ways, so the answer, of course, is absolutely yes. But I think moreover is like the feature identification. So the features are like, what are the pieces that you're feeding it as possible variables? You know, you can imagine it could be things that we sort of have in structured form, but it can be all kinds of elements that I think the real discovery will be kind of opening up how we get at more than just, okay, we know the year somebody graduated from school, or maybe we know what county they practice in. You know, what are sort of the next levels of features that can be identified, formed in some sort of structured way to be able to be incorporated. And then from there, I think the sky is really the limit in terms of identifying potential factors that haven't really been explored before.
I think one other thing that may be relevant here is just being careful with proxy variables. So when we do identify those factors, thinking through kind of what's the causal chain of how that's really having an impact on the end thing we're studying. So a lot of times zip code is a very high ranked feature importance predictor in models, but that's often a proxy for socioeconomic status and income. So just kind of thinking about once we've landed on those features, kind of how do they impact the end outcome that we're interested in, and trying to go upstream whenever possible.
Great. Yeah, I like that. I like that a lot. Yeah, I think we're just at about time. Is there anything else that that the panelists want to make sure everybody kind of takes away from this, or that we didn't get to? Any advice for us?
I think mine would be explainability and interpretability. Again, the word is humble AI, which is that if there are times the stakeholders or the public express concern, then model performance and efficiency shouldn't be the only rationale to force in variables. And as Allison mentioned, variables that are imputed from incomplete data need to be thoroughly investigated. There are cases where people's race are imputed from their last names. It's people intermarry all the time, and I don't think one should be that careless about imputation of socioeconomic variables.
Yeah, I'll do a tiny letter rearrangement on interpretability and add interoperability, because I think that the ability to, what interoperable data enables you to do is to test the models in your local environment as well. And so not only to see what someone's done, to really read and see it was well explained, but actually to take it and am I getting the same results that they got there, and why those reasons might be. So I would add that interoperability as well.
Great. Oh, Allison, did you want to say anything more?
Just going to say, I think that's a great note to wrap on, so I'm not going to add anything to that.
Perfect. All right. Well, thank you again to the panel. Thank you again to the audience. Some great questions. We could go on all day, but we are out of time. So thank you very much.
Thank you.
Thank you.